Okay, now let us do some important questions. One of the questions that I would like to do with you is, I've already given it in homework, but still, question 6.2, exercise question of NCERT chapter 6 we are doing, which is on page number 134. So look at this question. So it's just a recap of what we have done. A body of mass 2 kg initially at rest and moves under the action of applied horizontal force. So this is the mass that you have. And horizontal force of 7 Newton is applied on it, on the table, and coefficient of the kinetic friction is given to you. That is coefficient of the kinetic friction is 0.1. Now what you need to find? You need to find the work done by the applied force. So the first part is work done by the applied force. So students, you need to be very particular what kind of work is done by which force. So applied force. So work done by applied force is force applied into the displacement. And the time given here is 10 seconds. So that's the time. But I don't need time, I need displacement. So I need to calculate first this distance or displacement for the time 10 seconds. So in 10 seconds I hope this box will be here. So time is 10 seconds. Now this is the force applied. How many forces are acting on it? See, we have
4.
Force of friction, yes. So this is mg, and this is your normal reaction, normal force acting on it. So 4 forces are acting on it. Obviously both of them are equal and cancelling out each other. How can you say they are equal? See, force in y direction, sum of forces in y direction is 0. Why this is 0? Because displacement in y direction is 0, and this thing is telling me that the net forces in y direction is 0. So students, understand that there is no displacement in y direction, so that is why the net force in y direction is 0, right? So what is force of friction? I know the applied force, this is the applied force, but what is F? So F is equals to mu k into this normal reaction. Yes, that is what the force is, and what the normal reaction equals to. I have just discussed that they are equal, so that is equals to mg. So what will the kinetic friction equals to? So the kinetic friction equals to mu k, which is 0.1 into m is your 2 kg. So this is 2 kg, right? So 2 kg, and g here we are taking as 9.8. So what is the force of friction? So force of friction is 1.96 Newton. So that's the force of friction. So the body moves in 10 seconds. I want to find out the time. My time is given to me. I want to find out the displacement. So what is the formula of displacement you have? You have two formulas of displacement, which is equations of motion. S is equals to ut plus half at square, and v square minus u square is equals to 2as. So the point is that to use these formulas, for this formula I need u. So u, I know that u is 0. U is equals to 0. That's what I know, because it starts from rest. So u equals to 0, because it is given in the question that the mass initially at rest. So I know that's okay, but I don't know the final velocity. Okay, I don't know acceleration. I'm going to find out this s. I know the time, so that is why I will be using this formula. So to find s, but to find s, I need a. So this v I don't have, so I'm not going to use this formula. Now I need a. Okay, so from which formula I will get a? So I know the formula, F is equals to ma, but this AF is always net force. This is always net force. So what is the net force here? This 7 Newton in this direction. Student, this is very important question. I'm deliberately taking this question, very important. So always when we have questions of pulleys, when we have this kind of question, always you have to do one thing, that is greater force minus smaller force. That is your net force. That is your F net. Greater force minus smaller force is equal to, obviously, the acceleration will be in the direction of greater force. So this acceleration is definitely due to the greater force. So in the direction of greater force. So F net. So here you have two forces. This is 7 Newton. This is 1.6 Newton. So what's the direction of greater force? What is greater minus smaller? So greater force is F applied minus smaller force is F. And that is equal to MA. So A is in the direction of greater force, FA. So FA is 7 Newton minus, what is force of friction? 1.96, and that's equals to mass, that is 2 kg, into acceleration. So from this equation I found the acceleration to be 5.04 divided by 2, and that is equals to 2.52 meter per second square. Now put this acceleration in this formula. So putting the acceleration in this formula, I get s is equals to, so u is 0 plus half into acceleration is 2.52, and what's the time? 10 seconds. So SI units, MKS, Joule Newton. So meter, kilogram, second, joules, Newton, right? So time should be in second. Okay. So now students, this will be cancelling out 1.26, and displacement is equals to 12.6 meters. Now I can find the work done by the applied force. So this is square, right? So So I need to multiply it with one more 10. So that's 126 meters. Now the work done by the applied force is equals to, so both are in same direction. So the theta is 0 here. So that is why I am directly writing it F into D. So that is 7 into 126 meters. That comes out to be 882 joules. So students, see that the work done by the applied force into displacement. So here I am only concerned about the displacement. I am not concerned about the other forces acting. I only want to know the displacement and multiplied by the applied force. So this is the work done by this applied force. Right? Now what is the work done by the friction? Work done by the friction will of course be equals to friction force, and here you have this, how much is the angle between the friction force and displacement? So friction force is in this direction and displacement is in this direction, so the angle is 180 degrees, so it will be negative, so minus FD, that's equals to minus 1.96 into displacement is 126 meters, and this comes out to be minus 246.9 joules. Now third, work done by net force. So that's your net force, 7 Newton minus 1.96, that is 5.04. So net force is in which direction? It was in this direction. So the direction of displacement and net force is same. So net force into displacement, so theta is 0 here. So FD, and this will be equals to 5.04 into displacement 126, and this comes out to be 635 joules. Right. Now I have one more part in this question. What is the change in kinetic energy? So I know that work energy theorem, work is equals to change in kinetic energy. So what is the change in kinetic energy here? So work done, students, always remember, this work done is not this work done by the net force. This is not this work done. This is work done by all forces. Okay. This work done by all the forces. So what's the work done by all the forces? So is this and is this same? Here also it is the net force. Yes. So of course this and this is same. Right? Work done by all the forces. So you have taken all the forces here, because this upward and downward force, the net resultant is 0, and this thing and this thing. So you have considered all the forces. So the answer is 635 joules. Students, please don't go by the style of solutions of any book. You are supposed to have your own style of solving the problems. Don't copy the solutions. You will not be able to learn physics. You can only learn physics when you solve the numerical in your own way, and after solving it, after doing it, then you can look at the solution from the book also. Okay. So
Yes, sir.
good. Now we'll do the same kind of problem but for the inclined plane. So that will help you in doing the question related with the inclined plane. So students, very important class, today's class is very important. Now the question that I am going to take is example, I have given it in homework also, example 23, page 6.12, ऐसे होगा. Very important question. So what this question is about, same question means same in the sense is here also we need to find the work done by different forces, and at the end we need to find the kinetic energy of the body. So but here the plane is inclined plane. Students, bigger the diagram, always remember, bigger the diagram, better for you. So let us make a big diagram. Easy to understand. So I have a mass, a body of mass 0.3 kg, and I have taken it from here to the top, and then this height is given to us, this 5 meters, this height. And then it is allowed to slide down, means no force is applied when it is coming down. You have just leave it here from the top. So you have taken it to the top, you leave it there, and then obviously it will come down. So the length of the inclined plane is 10 meters. So this length of the inclined plane is 10 meters, and the height is 5 meters. The mass, so it was somewhere in the middle, suppose when I was taking it upward or downward, doesn't matter. The mass is 0.3 kg, so I can write it as 0.3 here. Let me write it here, 0.3 kg. Okay. The coefficient of friction between the body and the plane is 0.15. So coefficient of friction is given to you, that is 0.15. So students, those who have not done the last chapter, force of friction is nothing but the formula for the force of friction is, and it is the kinetic friction that we are dealing with here. So coefficient of kinetic friction into the, we just did into the normal reaction. Normal reaction is the force. Why we call it normal? How does it get the name normal? Because it is normal to the surface, always normal to the surface. That's how we get this name. So students, the nomenclature of physics is given, the names are given with some intention. So what is the direction of normal force? It is, so this is your plane, so it will be perpendicular to the plane. This is your normal force. Okay, so this normal force in the last question the normal force was here, as it was horizontal surface, the normal force was mg, because there was no displacement in vertical direction. But in this question you can clearly see that there is displacement in vertical direction going on. There is displacement in horizontal direction also going on. So it means here this downward force is not equal to upward force, of course. So that's the difference. Okay? Good question. Now, definitely this angle will be given to you. This angle is theta. If it is not given, then we'll assume it. Now, we need to find the work done by the gravitational force for the round trip. Round trip means from here to here and then coming back. Okay. Work done by the applied force only for the, so this is for the round trip. So this is for the whole trip. And this applied force is only for the upward journey. Then frictional force again for the round trip, because in the down trip you are not applying any force. That is why it is only for the up trip, because you have applied the force only to take this 0.3 kg mass from here to here, and you leave it over there and it came down all by its own. So no applied force in the downward direction. And then you need to tell the kinetic energy final here. So at this point, when this box was coming down, what is the final kinetic energy over here at this point? So these are the four things: 1, 2, 3, and 4 that we need to do. So work done by gravitational force. Yes, student, this is very important question. See, the gravitational force is conservative force, okay? And the frictional force is non-conservative force. So we'll do the concept of conservative and non-conservative force also. So work done by conservative force and by non-conservative force. Okay. This also we need to understand, because conservative force here is your gravitational force and non-conservative force is your force of friction, which is F. Let us start the first part. Work done by the gravitational force in, so it's a trip, so we will find the work done in taking the body upwards, and then work done by the gravitational force in taking the body downward, right? Okay. So we know the formula of work. What is the formula of work? Work is equals to, when there is constant force, so of course gravitational force is constant force, that is equals to F dot S. Now, if they are in the same direction, if the theta is 0, so this is Fs cos theta. So if theta is 0, then we can simply write work done is equals to force into displacement, and if theta is 180, then we can simply write minus Fs cos 91. Okay. Now, this was one aspect of this formula. Another aspect, work done is equals to Fs cos theta. Good. So I told you that I can write this in two ways. I can interpret this work done in two ways. That is F into S cos theta, and this is F cos theta into S, you can write. Okay, so here this means that if this is force, this is a displacement, this is angle theta. So drawing a projection of force on displacement, so this will be F cos theta. So this is F cos theta, means the force in the direction of displacement. Force in, so what is the meaning of F cos theta? F cos theta means force in direction of S, displacement, and then multiply by displacement. Okay, what is this? What is this? This is, so this was your force, this was your displacement, so draw a perpendicular over there. So this distance is your S cos theta. So here projection of F on S, and here projection of S on F. So means this force into displacement in the direction of force. I have taken this displacement in the direction of force. S cos theta means displacement in direction of force. So this is displacement in direction of the force. So students, you need these kind of formulas when you will be doing higher order thinking skills question, NEET questions, IIT questions. Yes, these tricky. So this is the trick, that either take force into displacement in the direction of force, or either take force in direction of displacement into displacement. So both are supposed to be in the same direction. So here, work done by gravitational force is, so theta is, what is theta? So what is the direction of gravitational force? So that's the direction of gravitational force. It's always, this is the direction of gravitational force, always vertically downwards. That is mg. So, and where is the displacement in the up trip? So it's the whole trip. So I'm first calculating for the upward journey and then for the downward. So for the upward journey, what will be the angle? So upward journey means up, and this is downward. So work done will be negative, right? So I can write it as minus F S, right? But I told you that this force, either take the force in the direction of displacement or take the displacement in the direction of the force. This is what does it mean. So force is mg, so minus mg, and how much the displacement upward? The displacement is 5 meters, right? So that's your height here. So minus mass is 0.3 kilogram into g is 9.8 into 5, and this comes out to be minus 14.7 joules. Yes, do you agree, students? This question is going to teach you a lot.
Yes,
Okay. So it means the work done by gravitational, so the work done by gravitational force is negative, because of course this is downward and the displacement is upward. Next part, for downward journey, gravitational force, now force is in downward direction, displacement is also downward, so that's Fs now, and that is equals to mgh. So that's equals to 0.3 into 9.8 into 5, that's plus 14.7 joules. So work done is a scalar quantity. So work done for the trip by gravitational force is equals to up trip plus down trip. So minus 14.7 joules plus 14.7 joules, that's equals to 0. So there's no work done by the gravitational force. So that's the property of conservative force. So now we know that this is a conservative force, and conservative forces depends on initial and final position. They do not depend on path. Path not concerned with. They only depend on initial and final position. And second thing is that the work is stored in the form of potential energy, means the work done by the gravitational force here is equals to minus this. So this is, so work done is equals to, so potential energy here you can take it as 0, and here the potential energy is 0.7. So this potential energy we can use as symbol U or symbol V. We will be using U. So work done is change in potential energy by the conservative force, but the sign is negative. Sign is negative. Okay, so work done is equals to minus delta U. So as it depends on initial and final positions, so directly we can also write or work done whole trip by Fg is equals to force into displacement. So what is displacement? Final position minus initial position. So final and initial is same. So Fg into 0 is equals to 0. So you have seen this thing. So do it with this formula and or directly do this. This is what you need to do. So displacement is 0. So force into this is 0. Now the second part. Work done by the applied force, only for the up trip we have applied that force. So work done by the applied force is equals to, so we can also write it W1G, W2G, okay? Not WG because it will be different, either write WG or W-G, okay? Or 1, 2, I told it in the last lecture. Now, the applied force. So how much is the force you are applying? So now we need to deal with all the forces. So you are applying the force in upward direction, right? Along this plane. If you are taking the displacement 10 meters, so you are applying the force upward. Now what other forces do we have? Of course there is this force of friction against the direction of the motion, and what about the component of mg in this direction? Gravitational force also has a role to play. So how do we resolve the components of Fg? See students, this is angle theta. So this will be angle 90 minus theta, right? If this is 90 minus theta, this will be this and this, they are corresponding angles. So this will be 90 minus theta. And if this is 90 minus theta, then this angle will be theta. Okay? So you need not to do this much of maths every time. You can directly write this angle as theta. So this and this angle is same. Let me tell you again. This angle is theta. So this angle is 90 minus theta. Third thing is that these two are corresponding angles, so this angle is 90 minus theta. And this is the fourth thing, that this theta, this is 90 minus theta, so this is 90 degree angle, so 90 minus theta, so obviously this is theta. So this angle and this angle are same. Now this is your FG. So what is the adjacent component? So of course this component is of same length, because this is of same length, students, so this component will be up to here actually. So resolving the components. So what is the F component of FG here in this direction? So this is adjacent. So adjacent is equals to FG cos theta, right? And what will be the what will be in this direction? The component FG. So this is FG sin theta, right? In this direction. So students, along this 10 meter inclined plane, there are three forces. One is friction force, which is pulling it down. There's another force which is pulling it down, that is Fg sin theta. And your applied force is taking it upward. So here, you are taking it upward, so it means that, and you are taking it upward with no acceleration actually. There is no acceleration. So students, this question will be better if it is given that acceleration is 0. Okay? That's what you need to take. So acceleration is 0 means force, according to Newton's first law, net force is equals to m into a, and if a is 0, it means F net equals to 0. So net forces are 0. It means that Fa, the net force in this direction, is equals to the force in downward direction. So F plus Fg sin theta. So now this is Fa, F plus Fg sin theta. So put this value, you will get the force, and now the work done will be this force Fa into the displacement, and displacement is 10 meters. There is no problem with the displacement. Okay. Now, so this is the force. So what is F equals to? F equals to, this is another good question. What is F equals to? So F equals to coefficient of friction into the normal force. Here the normal force is equals to Fg cos theta, right? So that is equals to Fg cos theta into nu. So nu into n, and nu is given to us in the question. Nu is 0.15. Okay. So nu into, and n is equals to Fg cos theta. Okay. So normal reaction is always equals to the force which is acting in the direction of normal reaction. So students, this work done by the applied force, we can write it as, so this is what force of friction is. So the applied force is nu Fg cos theta plus Fg sin theta, and theta is 30 degrees. It is given to us that theta is equal to 30 degree. So this new Fg cos theta plus Fg sin theta, this is our Fa, into the displacement. So that's equals to, now what is nu equals to? 0.15. What is Fg equals to? Gravitational force, that's equals to mg. So 0.3 kilogram into 9.8. What is cos 30 degree? So cos 30 degree is root 3 by 2 plus, what is Fg? Fg you can take common also. So Fg is mg 0.3 into 9.8. What is sine 30? 1 by 2. What is displacement? Displacement is in the direction of force. So I told you, displacement, I have taken this force and displacement, they are in the same direction. So that's 10. Displacement is 10. So students, you can solve this and it will comes out to be 18.5 joules. So that's the force you have applied in taking the body upward. Now you need to find the force of friction for the whole round trip, work done by the force of friction. So that's equals to, so it will be for the first up trip and then it will be for the down trip. So for the up trip, let take W1F. So W1F is equals to minus, so what's the friction force? That is nu into n. We have written it. So that's nu Fg cos theta. So force of friction is downward and this is, see, always the angle is 180 degree, always, because it is in the opposite to the direction of motion. The friction force is, it's a resistive force. So this is minus nu n. So that's what it is. So nu is minus 0.15 and into what n is, Fg cos theta. So Fg cos theta is, Fg is your 0.3 into 9.8 and cos theta is root 3 by 2. And what about down trip? Work done by friction force. That is again mu n. Okay. So that will be the same as above. So net work done by the friction force, you can calculate it. You can simply multiply this one with 2. Okay, so 2 will cancel out here. That's equals to minus 2 mu n you can do, and just simply multiplying it with 2, I hope you can calculate it. So that comes out to be minus 6.7 joules. Now the students, the point is that I was discussing with you conservative and non-conservative force. So the conservative force depends on path. So here the conservative force, you directly use the displacement as 0 and you can directly calculate it as 0. But that's not the case with the frictional force. So frictional force depends on path. Okay, so it is non-conservative force. You can see the work done in the round trip is there. It's not zero. Here it was zero because upward was exactly equal to downward, so it was cancelling out. But in opposite direction, the work was positive for upward journey and negative for the downward journey. But here, because in this case theta was 180 degree and in this case theta was 0 degree, but here in both the cases up and down, because it is the resistive force, so theta is 180 degree in both the cases, in upward journey and in downward journey. So that is why these non-conservative forces, they are sort of resistive forces. Okay, so like air drag, we did one question of the air drag. Air drag is also non-conservative force. The viscous means the even in liquid we have drag forces. So all the resistive forces which resist motion, so that is why they depend on the path, and always this work done will be negative by them, opposite to the direction, if the displacement and resistive force, of course, they are in opposite direction. So you are understanding a lot of physics from this question, I hope. And now we have fourth part of this question, and that is the kinetic energy of the body at the end of round trip. So we know that work done by the net forces is equal to change in kinetic energy, right? So kinetic energy at the end is kinetic energy initial minus kinetic energy final, and initial was 0, right? So here initial kinetic energy, body was at rest when it was allowed to come down, so kinetic energy is 0. So 0 minus kf, so that's the work net. So net work done, so what's the net work done? Work done by gravitational force plus work done by applied force plus work done by friction force, that's equals to minus kf, final kinetic energy. So now gravitational force, work done by gravitational force is 18.5. Work done by the applied force was 18.5. Work done by the gravitational force was 0 for the whole trip. But here the work done, we are only talking about this downward thing. Okay. So only for the downward journey I am talking about. Only for the downward trip. So this was W1G only. This applied force in upward action, and here also this is only one. So students, we need to be careful about this. We are talking only about the change in kinetic energy for the downward journey. So the downward work, sorry, not the upward. So there is no downward work done by the applied force. I hope you have understood this. So W1G we have taken for the upward journey, we have taken these work done by the applied force and work done by the friction force. For downward journey, W2G and no applied force and W2F. So for the downward force, work done is equals to, for the downward, let it be W2 for the downward, and that's equals to change in kinetic energy theorem. So what is W2G? So W2G was 14.7 joules And what is W2F? Work done by this friction force. That's minus, so half of 7.6. So half of 7.6 is this value. So that's 3.8 joules. So this 3.8 joules and that's, if I want to find the absolute value of the, not indulging into this negative positive thing, that will be equal to the final kinetic energy, and this comes out to be, if we subtract it, it will comes out to be 10.9 joules. So students, you need to do these questions all by yourself with your own understanding. Both these questions quite important, have taken a lot of time just to discuss each and every aspect of the question. I hope you have understood it. Now as
second part बता दो sir.
Yes.
Second part.
Yes. Which part?
Second part.
Second part. Second part is we have to calculate the work done by the applied force only for the upward journey. For the downward journey, there is no force applied. The box came down all by its own. So work done by the applied force for the upward journey is the force applied into the displacement. What is force applied? Force applied, here I am taking this box with acceleration 0. So acceleration 0 means the net force is 0. So net force 0 means the force in this direction is equal to a force in this direction. So the force applied is in this direction over the inclined plane, and the force in the downward direction was force of friction and a component of gravitational force, which was Fg sine theta. So Fa is equals to friction force plus Fg sine theta. So that's the way how you have calculated the applied force. So applied force was equals to force of friction plus Fg sine theta. So you have put that value for Fa. So this friction force is equals to nu Fg cos theta plus Fg sine theta into displacement. Okay. And students, this will also be uploaded on the YouTube channel, so you can watch this video again, and any doubt you can ask it in the next class. But yes, definitely you need to do these questions once or even twice, because it is teaching you lots of physics. Now the next topic is conservative and non-conservative forces. I have already discussed with you the conservative and non-conservative forces. So conservative forces means your gravitational force is conservative force. Now so the work done by the applied force, I have raised this ball, suppose, to height h. So this was the ball over here and I have raised it to height h. So work done by the applied force, force into displacement, and now see again the same thing I am applying here, students. Acceleration is 0 when I was taking this ball up. This is the assumption which is required. So then only the applied force, upward force, is equals to, because acceleration is 0. So I was taking it with infinitesimally slow constant speed. I was taking it with constant speed, and there I was taking it on the inclined plane. The last question, that box, acceleration was 0, and that is why Fa was equals to F plus component of gravitational force Fg sine theta. So that is why Fa was equals to F plus Fg sine theta, because these forces were same, because acceleration is 0. So F net is equals to ma, force is equal to mass into acceleration. I told you. And then I told you that this force is greater force minus smaller force is equals to ma, you need to write. But here this a is equals to 0. So the greater force and smaller force both are same. So these both are same. So that was the way of calculating the applied force in the last question. Similarly here also I am calculating the same way applied force, because here the acceleration is 0. So that is why the applied force and gravitational force are same. I am taking this ball upward with infinitesimally small speed. This is the assumption, students, that you need to take. Then only this whole work will be stored in the form of potential energy. So this is very important assumption. And this thing you will need in 12th class also, when you will be doing the electric force. So same concept, if you learn it here, it will be very easy for you to apply for any conservative force, it will be same. So electrostatic force, electric force that we'll do in 12th class is also a conservative force. Okay. So now assumption is a equals to 0. So work done is equals to Fa into the displacement. So both are in same direction, Fa and displacement. So theta is 0 here. So I need not to tell this thing again and again. If I'm writing directly, it means theta is 0. So force applied is equals to Fa is equals to Fg, because acceleration is 0. So the magnitude is same. Of course the direction are different, but I am taking the magnitude here. So that's mg into h. So that's the work done by the applied force. And if you write the work done by gravitational force, of course the angle is 180 degree. So you'll find it minus Fg into h. That's minus mgh. And that is why if you take the ball up like this and allow the ball to come down, this potential energy will be converted into kinetic energy. But the net work done by the gravitational force, not by the applied force, work done for the trip, work done by the gravitational force will be 0, because that's what because it is plus mgh and then minus mgh, and for the trip it will be 0 by the gravitational force. So we are talking about the up trip. So this is about the up trip only, up trip. I have raised the ball to height h. So these are the work done by the gravitational force. And if you find in the down trip, work done by the gravitational force, you can write it as Fw-g. And now both the forces are in the same direction. Fg is downward and you are coming down by the distance. So that's Fgh, and that is equals to mgh. And this will cancel out. And work done by the gravitational force for the whole trip is equals to 0. So that's what so that we have discussed with the last question also. So students, very important concept. So work done by applied force is plus gh, work done by the gravitational force for the up trip is negative. And this is stored in the form of potential energy. And this is a function of h. More is the h, more is the gravitational, and this will be equals to minus uh. Okay? So this is for the whole trip, if I am taking this upward trip and downward trip together. Good. Students, watch these videos again if there is any issue. I told you that in the book it is V written as potential energy, but it's U, because in 12th class also you will be using U symbol. So let us use the symbol U for the potential energy. So this is the U symbol for the potential energy.
Excuse me, sir.
Yes.
So we use V symbol for potential difference now.
Yes.
And use for potential energy.
So your voice is not audible, miss. It's not properly audible. What do you want to ask?
Sir, I'm just asking for the symbols.
Symbols.
Yes, sir.
So here we have letters actually. All these are letters. Symbol is theta here. Theta is also a sort of letter, you can say. All these are letters, alphabets. Yes. Which symbol? You are discussing about U and V?
Yes, sir.
Okay. See, it's your choice. You can use V also, you can use U also, but normally we use U for the potential energy. We use V for the potential difference. That is why I am not using V here. I am using U here.
Okay, sir.
Okay. So now this was your equation 1 and this was your equation 2. Very important equations. Now I am concerned with students. Now forget the force applied. Forget about the work done by the force. We want to deal with the fields, with the force applied by the field. Means we want to deal with conservative forces. So conservative forces. So two conservative force we'll deal with. One is your Fg, gravitational force. Another will be the spring force. And in 12th class you will deal with electric force. So these are the. So this is spring force, electric force, and gravitational force. So we will be dealing with these forces. Okay. So forget about the applied force for the rest of this chapter. Okay. So now we are dealing with conservative force. So we will be dealing with the work done by the gravitational force and okay. So we are dealing with equation 2, right? Forget equation 1 now. So equation number 2 means taking the ball up, work done by the gravitational force is equals to minus Fg H, and that is equals to minus mg H, right? Now differentiating both sides with respect to H. So differentiating both sides with respect to H, because H is the variable here. Okay. And now this will be, so let us write this side first. Mg is constant, so taking outside dH by dH, and that's equals to minus. So this is stored as minus UH, right? Stored as potential energy. So that is d by dH of U. Okay. So U is a function of H. So I've just differentiated this equation with respect to H. What do I get? I get mg. dH by dH is 1. Mg equals to minus dV by dH. And what is mg? Mg is the gravitational force. So this is mg, gravitational force. It was acting downward. I was taking the upward direction as positive. So this is negative direction. So this is Fg was of course minus mg, downward direction. So that's why this, and minus dV. So you can write U instead of V. In the book it is V. Don't get confused. So let us write U only. U as a function of H by dH. So students, that is very important equation, very important Gravitational force is this. Okay, done? Yes? Now, let us release the ball. If the ball has gone up, it will come down also. We cannot keep the ball in air. Okay. Now, the ball is released. So this is the final velocity. This is your h. Now I am taking this downward direction as positive now. So what are the formulas do we have? V square minus u square is equals to, so ball is released. So that's what happened with the gravity, with the conservative forces. When you release the ball, then due to conservative forces, the potential energy is converted into the kinetic energy. So the potential energy, as the ball is released, the potential energy stored will be converted to kinetic energy, and that is equals to 2gh. So v square, so u is 0, so v square is equals to 2gh. Another very important equation, will need it. So now I'm telling you that this is changed into kinetic energy. So what is the kinetic energy? I'm interested in kinetic energy here. So kinetic energy, you need to multiply with half m both sides. We have done it earlier also. So this is kf, final kinetic energy, and what this mgh equals to. So mgh was equals to your potential energy which was stored, right? So this was the potential energy over here, mgh, right? And this potential energy is exactly converted to kinetic energy. So this is another property of, so this all we are doing conservative force. So I am telling you that the potential energy stored is converted into kinetic energy. And so now if you further take in one dimension, see the concepts are same, but we are writing them somewhat mathematically, proving them. Again, general case in one dimension. Now this was particular case, conservative force. So if we talk about as a general case, of course in one dimension, we can rewrite this equation. This equation 1, you can say this equation 2. We can rewrite equation 1 Fg is equals to minus du by, so instead of in one dimension, so I can write it in terms of x instead of h. This is the only difference. So because general case, instead of h I am writing it in x1, okay? And as this is conservative force, so I am removing this g also. So now this I am writing for any conservative force. Is this clear, student? This was for gravitational force Fg. Now that was related with vertical height, but now I am taking this case for any conservative force. Okay, so that is why I have replaced h with x. It is still in one dimension. So now what is, so we can, I can write this as F, this is also this conservative force, this is differential form. I can rewrite this differential form as F dx minus du. I can write it like this. Now I want to integrate it. So integrating both sides, what do I get? Xi to xf f dx is equals to minus ui uf du. Now what is this? This is the work done by conservative force, and see, this is work done by variable force. So let me tell you with the help of very simple example. In electrostatic field, it's easy to understand how it is easy. See, the force acting between these two charges is inversely proportional to the square of the distance. So this force, which is electric force, depends on the distance between them. So that's your x here. So this force is also a function of x. This is what I want to say. This variable force is also a function of x. Okay? So this is the work done by the conservative force, and that's equals to, what is integration of dx? That is equals to x. So this is u minus, of course, here ui to uf. Okay, and that's equals to minus, so put u is equals to uf minus u is equals to ui. That is negative of final minus initial is always change, so work done is negative of the potential energy for any conservative force, for any conservative force. This we have done earlier also, isn't it? That, okay, so here it was Fg is equals to minus UH. So how is that become minus UH? See, students, it was earth over here. You have assumed that u is equals to 0 here, and here you have assumed u is equals to mg, and change in height was h here. So change in height is h. Of course, you can write delta h or h, it's the same thing. So see, you have assumed here that potential difference is 0. Oh, sorry, kinetic energy is 0. But kinetic energy is not even 0 at the surface of the earth. This is your assumption. Okay. So we'll discuss more about it. But this you can assume anywhere. That's your choice. Where you are assuming the kinetic energy as 0. Because work done is change in potential energy. Change in potential energy. So potential energy is not important. Potential energy, only U is not important. It's not important. What is important is the change in the potential energy. For us, that is the work done. So we'll discuss more about this, students. But for the time being, and this also tells that the work done depends only on the final and initial position and is independent of the path. So work done depends on initial and final positions and not depend on the path, because initial and potential energy, final potential energy, irrespective of how you have taken it upward, directly upward or this way, and taking upward. So independent of path. This lecture is very important. You can watch it once more also. Now, if you want to take the dimensions of potential energy, what are the dimensions? The potential energy is mgh. You already know it. So dimensions of mass is m. Those who are new students, so we write everything in terms of mass, length and time. Okay, so m is the mass. What is this? G is acceleration due to gravity. What are the units of acceleration? Meter per second square. So meter is length, per second square is second is time, so t raised to the power minus 2. And then we have height. Height is length. So what is the dimensional formula now? M, and then L1 plus 1 is L square, and then t raised to the power minus 2. So that's what the dimensional formula of potential energy is. Now what are the SI units of potential energy? So SI units of potential energy is, of course, joules. Okay. So that's all for today, students. I know